Hello, my name is Mercado, and I'm doing a podcast for my fundamentals of physics class. And then in this podcast, I will be doing an experiment showing density, volume, and buoyancy. In this experiment, we'll be testing out three objects. We'll be testing out a soapstone block, a rubber duck, and a can of miscellaneous meat. Well, first we'll be taking this can and placing it into the body of water. And as you can tell from the volume of the water already, as you place the can into it and let it sink to the bottom, the amount of water will increase. If you take this value and subtract it from the original value of the water, you'll be able to figure out the exact volume of the can. Now, if you take this soapstone block, which you can tell it's porous, and place it into the water, it floats on the top. And it floats on the top because it's less dense than the water, and as well as its buoyancy created by the pores in the soapstone letting air keep it afloat. Now, if you take this rubber duck, as we all know, rubber ducks are made hollow. And if you place it on the water, you can't really get an accurate read of its volume because it doesn't go into the water or submerge, but it floats on top of the water because its buoyancy is very great. And the reason why is because it's hollow, and like many boats made today, they don't make the boat out of a solid piece of metal because it would just sink to the bottom. They leave open spaces inside of it so it can float on top of the water, as well as how they make this rubber duck. If this rubber duck were made out of solid rubber, it probably would not float on top of the water as it does, but sink a little further. So in this project and experiment, it's optimal to tell an object's volume by placing it in a body of water and just taking the difference of the starting volume and subtracting it from the end volume, and as well as testing out buoyancy of multiple objects by how they float in the water.